Hello and welcome to Elektor Engineering Insights, the show that puts your engineering challenges to the industry's experts. I'm your host, Stuart Cording, and this is our first show. So what's the idea behind the show? Well, regardless of the segment you operate in, from automotive to medical or industrial to white goods, there is information aplenty. Every supplier has a website, data sheets, application notes, tools, and development boards. The challenge is sorting through all this information to find the pieces relevant to your application. And even if you do discover the relevant pieces, not all of them make sense or functions described as you start prototyping. Now, a lot of our engineering audience will work for large organizations, and if that is the case, there are probably plenty of colleagues to turn to. There you'll find a wealth of experience and ideas as to how to resolve the challenge you face. However, there are others in smaller teams or working alone. If no one in the team has seen the issue before or attempted to implement the function or feature desired, you end up a little stuck. And while many suppliers provide excellent support, it can be lacking with others. So where do you turn to next? Well, exhibitions are a great way for small and medium-sized businesses to speak directly with component, tool and system suppliers. Often their team of application engineers is on the stand at the exhibition and happy to chew the fat regarding engineering difficulties. However, the world is still gripped by COVID. Even if exhibitions and in-person events recovered this year, many employers may still have travel restrictions in place. Furthermore, we have no idea how this global pandemic will develop in the months to come. So we have to assume that, unfortunately, there is a chance that our favourite exhibitions and congresses may not happen. Well, not in person, where the value is for many visitors. So where does Elektor come in? Well, during the pandemic, we ran our Elektor Helps campaign, supporting businesses to get the word out when alternative options were restricted. Also, through our articles focused on industry topics, we've reported on what's been going on to keep the engineering community informed. This has ranged from the engineering and maker response to the COVID pandemic to the semiconductor crisis and the availability of the chips you so desperately need. To broaden our reach, we've decided to launch this show, the Elektor Engineering Insights, to provide an alternative medium through which we can connect engineering professionals. Going live on Wednesdays around once per month, we're going to be inviting experts from different fields to discuss a range of challenges around everything from embedded system development and power supply design to wide bandgap technologies and IoT. To ensure that your voice is part of what's going on, join us in the conversation. You can join in with questions during our live shows. We're streaming on LinkedIn, Twitter, and also on the Elektor TV channel on YouTube. So regardless of where you're watching, you can post your questions and comments, and we'll do our best to get answers or guide you to resources that might help. Between the shows, you can also get in touch with me, Stuart Cording, directly via email or Twitter. And if you'd like to learn what topics we'll be covering in the future, and who's going to be joining with us, then look at when the show streams are going to take place on our dedicated page at the Elektor Engineering Insights site, where you can find it all at ttcr.at/EEI. So with that, welcome to the show. Thank you for joining us today. And I'd like to introduce my colleague, CJ Abate, who's our Technical Content Director, and add him here into the conversation. Hi, CJ, how are you?
Great, how are you?
I'm very well, very excited and enjoying my first 5 minutes of the show.
Yeah, it's great. I was thinking today, I believe it was 2 or 3 years ago, I was in a coffee shop here in the US talking to you on Skype about the possibility of maybe a podcast or a live stream or something. And we've had the idea going back and forth a bit over the last 2 or 3 years, and now here we are. So this is great.
Yeah, it comes full circle.
Yeah. So I'd like to introduce you to our audience and get some information about your background first. Elektor readers all over the world know you, but some of the people on YouTube might not. So why don't you tell us a bit about your background?
Yeah, so I grew up in the UK and I always had an interest in electronics. I grew up with a Commodore 64. We talked a little bit about that as we did the 60th anniversary magazine for Elektor recently. And yep, you got a copy
right
there
here,
with you.
right here. Yeah.
And I think like many children of the 70s and 80s, we grew up with those 8-bit machines at home, and that was our introduction to programming and also into electronics. It was not just about writing programs for that machine, it was also about connecting sensors to them and outputting and controlling things as well. So it gave you that overall view of what electronics was about. Later, I went to university and studied electronics, and as part of my degree, I spent 1 year here in Germany, where I live today, in Munich, working for National Semiconductor, working on the development and design and testing of new microcontrollers. So my career sort of path was set with that, and the more time I spent in the electronics industry, I worked my way around at various different semiconductor vendors over the years. I was often employed in field roles, which means you go out to customers. So I spent a lot of time going to white goods manufacturers and people manufacturing automotive engine management units or electronic control units. And through those experiences, you spend a lot of time with engineers and you see the challenges they face on a day-to-day basis. You understand what sort of information they're looking for and where the struggle is in going from we have an idea to what components and solutions and software is available on the market to how do we actually then get all this working together as a complete system so that we can actually fulfill our target, which is bringing a product to market.
I think that's really going to be a focus for this show of yours. You know, we have a couple of other shows coming out soon on YouTube and Twitter and LinkedIn. Our lab team will be doing a show with kind of DIY tutorial type stuff. But with you, there's a bit of a focus on an engineering problem and a solution with an expert, correct? Or maybe two experts.
Yeah, exactly. So one of my stops on the journey to moving more into this sort of journalism role was working for microchip technology. And there I worked as a technical trainer. And every week we would run maybe 3-4 different classes on programming topics around microcontrollers. It went everything from basic 8-bit microcontrollers to the 32-bit machines. And then we also showed particular specific application implementation. So how do I create a USB-based device or connect over Ethernet, control a motor and so on. And what surprised me was not that there was interest in having that deep technical hands-on training over several days, which people came along to. It wasn't very expensive, so there was no very minimal barrier to entry. What surprised me was that the number of engineers that came along merely to ask a question. They saw that, they saw a course, yeah, it's interesting for me, but I don't necessarily need to know that now. But I would like to go there and ask somebody something very specific about how the compiler works or understand how this microcontroller feature is implemented. Because I'm struggling, I'm having problems with it. People would often just bring a complete system with them in a box. As a cardboard box comes out, all the wires, all the boards, and we'd sit there and analyze that. And for me, this show is going to be a lot about bringing professional engineers in together to talk about these challenges. We're going to have normally 2 or 3 guests from different companies who have an expertise in a particular area, and we're going to be asking them about what's the state of play today, what's the latest technology, which direction of things are going, but also what are the technical challenges when trying to, say, connect a display to a microcontroller, or how do I, move from silicon MOSFET technology to silicon carbide or GaN in order to do power converters, and learn from them and find out what's going on in order to let people move forward more quickly.
I think it's great. I mean, we have a web page set up for this, and viewers can read some of your articles there, but also they can use the Elektor website to get in contact with you. Maybe submit some questions ahead of time before your upcoming shows. So on the page for your show, they can see the upcoming topics and some of the upcoming experts as well, because I think that will be important to be able to interact with the audience.
That's right. So what would be great is if people do have questions to get in touch with me. I'm available on Twitter at Stuart Cording, for example. I'm also available on LinkedIn, so you can follow me there or contact me via LinkedIn, or just send us an email to stuart.cording@elektor.com. And if you've got some interest, some topic that you'd like to learn more about, then obviously we can try and schedule something around that and find expertise in that space. But also, if you see something scheduled that's coming up, then we'd be more than happy to accept some questions in advance. In fact, I've got a bit of a schedule which we can share here because we've been really busy in the last 24 hours.
Yeah.
Pulling up some people. Let me just pull it up here.
And I can say too, what's great is a couple of weeks ago, you reached out to me, and I believe it was even before Christmas time, and we ran a bit of a poll about topics that our audience is interested in, and a lot of those are going to be listed here.
Exactly, yeah. So what we're going to do is kick off on Wednesday, the 9th of March. Again, it's always at 1600 Central European time. And we've got two experts in the area of displays. Achim Döbler is a senior field application engineer from Actron AG. That's a company based here in the Munich area. He has an amazing wealth of understanding of all sorts of displays. I would say probably more in the area under 15 inches and mostly in displays that connect to microcontrollers. And that's an area which is quite challenging because microcontrollers need quite a lot of performance in order to make some reasonable type of graphical user interface. He's also developed a graphical user interface library, a lot of experience on the STM32 microcontrollers, and regularly makes lots of demos on different displays to show his customers how to use those to the best effect. And then our other guest is Alex Munden from Display Technologies in the UK. Now, their focus is more on industrial displays, single board computers for driving those, and displays which are enormous. These are the big displays that you would see at as advertising in a shopping center or in a airport or a railway station. They do smaller ones as well for sort of ticketing machines and things like that. And obviously another aspect of those displays today is the interaction. How do I press something, create a touch screen and make sure that it works reliably and robustly in the open air where it's exposed to the rain and wind and snow. So that's going to be an interesting first show. Mm-hmm. The next one, which I think is also going to be have a huge amount of interest, is on RISC-V. Now, this is something you and I have sort of seen regularly in the magazines, in the Elektor magazine. It's something that we discuss internally with the other engineers. With Matthias, for example, he's really keen and interested in RISC-V as well. So RISC-V, for those who don't know, it's an open source, let's say, processor architecture. And it allows people to create their own products, microcontroller-based products, such as in silicon or as an FPGA. But the nice thing about this particular architecture, if you compare it to commercial solutions, is really the flexibility, the ability to modify and change it. Obviously, that's a core element of all open source software. But the interesting thing with RISC-V is that you can develop your own instructions to do specific things that are not available in the instruction set as it stands. And that's where Martin Kroom from Green Waves Technologies comes in. His company has developed a processor called GAP. There's a GAP 8 and a GAP 9. And their focus has really been on enabling machine learning algorithms to be run on those processors at very, very low powers in order that you can have a battery-enabled device that can really run for a very long time, but do some very, very complicated sensing, such as vision recognition, face recognition type activities. So we'll find out from him how RISC-V has been deployed, how they go about creating their own algorithms and instruction sets on the device. And I'm hoping to get some other tools providers in as well to talk about how you test those and make sure they work before you actually then commit them to silicon. Obviously, that's an important part of the process.
On that note, on RISC-V as well, just so everyone knows, the March and April edition of Elektor, we have a Build Your Own RISC-V Controller article featured in that edition. Wow. So it coincides nicely with your show in April. That's
really good. Yeah, I'm looking forward to seeing that as well. That'll be an interesting one. Then we've got wide bandgap. We're still to confirm the participants for that particular show, but that'll be on the 4th of May on Wednesday at 4 o'clock. And I don't know, it depends what sort of line of work you're in, I guess, what sort of engineering challenges you're facing. But from what I've been seeing and the work that I get involved in, we're seeing a lot of interest in GaN and SiC in order to gallium nitride and silicon carbide power devices, MOSFETs, in order to replace things like IGBTs and silicon MOSFETs in applications such as power converters. Now, there's lots of advantages to using these. They're sort of much more efficient. They have lower on resistance, so you can save energy. There's not so much heat dissipation, and as a result, power supplies and power converters designed around GaN and SiC can be smaller, lighter. They generate less heat, so you can possibly get away with not using a fan. And this is really important for power supply designers, also for DC chargers for the automotive industry, for example. So there's some really interesting applications going on behind that. And that particular show is going to come out just before the PCIM event, which is running from the 10th to the 12th of May. So for those that don't know PCIM, PCIM is a show that's based here in Munich. Sorry, not in Munich, in Nuremberg, and runs every year. And it's a conference and exhibition focused on power electronics and intelligent motion, renewable energy, and also energy management. So it's a good opportunity to slide in and match the visitor expectations for PCIM, as long as, of course, it goes ahead, which isn't guaranteed.
Right.
And then on the run up to Embedded World, the show on the 8th of June on Wednesday at 4 o'clock, that's still to be confirmed. We've got some people lined up potentially in the spare area of IoT design, maybe some embedded software development tools. And of course, that's, as you see there, sort of in the run up to Embedded World 2022. Running from the 21st to the 23rd of June this year. Now, Embedded World also takes place in Nuremberg in Germany, and is focused on embedded systems, Internet of Things, solutions for e-mobility, and energy efficiency. And what we should note there is, of course, Embedded World typically runs in February, and has already been delayed because of the COVID rules here in Germany, which would have sort of restricted attendance, especially from abroad. It made it more difficult. So so we're seeing already the impact of COVID here. And again, sort of come back to the point why we're doing this. Our concern is, that the interaction is being restricted very much at the moment. So we desperately need these sort of live streams and shows to bring professional engineers in an open forum, in a chat environment, to talk about these things and help everybody out.
Well, I'm super excited that you're doing that with us. And I think it will be very useful whether these shows go on or not.
Exactly.
Definitely. Hopefully, Embedded World will happen though, because that will be great.
Yeah, exactly. No, I think for me personally, and many other people that I regularly meet at these shows, I mean, we're just really disappointed that the shows don't go ahead. On the one side, it's about catching up with old colleagues and friends, but also have an opportunity to physically see the products on display and talk to the engineers who develop the demonstrations. And it just gives you an idea of what's possible, opens up new opportunities for developing new products. And without that personal interaction, it really doesn't work. The online shows that have been offered really don't cut it in comparison, which is upsetting. That we haven't found a solution to really provide the same experience.
I do. Well, great.
Super. Good stuff. Okay. Well, thank you for joining us. Oh, sorry, I've lost you there. You disappeared for a second.
That's okay.
We're still learning how this works with this live.
That's okay. We're very excited on our end, of course, and we look forward to your next show.
Super. Thanks very much. So we'll say goodbye for now, and we're going to move on to take a look at what else Elektor does in between the shows. So For a long time, Elektor magazine has had a supplement magazine called Elektor Industry, and this year we've decided to integrate Elektor Industry into the main magazine. And the reason for doing that is quite simply that a large proportion of our readership are professional engineers. They work in engineering organizations on a daily basis. They're developing products. And one of the attractions of Elektor as a magazine is the combination of hobby and maker projects combined with the industry news and the industry insights that people like myself are allowed to contribute to the magazine. So what I wanted to do was just take a look back at some of the things we've covered in the last 12 months to give you an idea of the types of articles that we cover in the magazine, and perhaps give you some food for thought as to what type of topics that you might be interested in seeing in the show and recommending and showing to us, suggesting to us in the coming weeks and months. So obviously one of the biggest things that's happened in the last 12 months is the corona pandemic and the impact that that has on the delivery or the lack of delivery of semiconductors and other components for the electronics industry at large. So we went out and we talked to sort of research some of the causes of that, some of the background associated with that, and talked to many people. Many of my old colleagues actually in the industry helped me out, telling me sort of what was going on and what the real challenges were and how they were tackling those. So that was very helpful to everybody that gave us a hand there. But essentially, what happened back last year as Corona broke out was obviously everybody was working from home. A lot of the manufacturing sites for everything had to close in order to allow the pandemic to be brought under control. And because of that, many industries, and one of the ones that sticks out is the automotive industry, they cancelled their orders for chips that were supposed to be going into their products. Now, at the same time, because lots of people working from home, suddenly there was a lot of interest in additional tablets, computer monitors, mice, keyboards, webcams, etc., etc. And so the manufacturers of sort of consumer goods and PC peripherals went out to the semiconductor industry and say, hey, we need some more chips. So the capacity that was made was freed up by industrial purchasers and automotive purchasers was filled then by consumer goods purchasers. So around 6 months later, the pandemic was more under control. It was clear that the automotive industry could start manufacturing vehicles again, but by then 6 months had passed and all the capacity had been taken. So one of the things many people perhaps don't appreciate is that when it comes to semiconductor manufacturing, semiconductors take a very long time to be manufactured. A single chip can take up to 6 months from start to packaging and test before it can actually be then put in a tape and reel and sent to a manufacturing facility to be put on a printed circuit board. So if you're placing an order today, you're not going to see anything for 6 months, and that's if there's any capacity available at all. So the result of this was that we've seen in the automotive industry, lots of cars being placed in parking lots. They're sitting there sometimes with some features completely missing and then being sold with certain ECUs actually not part of the package. In other cases, the vehicles are just sitting there waiting because there are no parts to implement important parts of the car. So they're just sitting there almost finished, waiting for whenever the missing chips and other components are going to be delivered. What this has sort of thrown up is the importance of forecasting. And I think with large organizations, obviously the purchasing teams, that's all a lot more under control, but it's the small and medium-sized businesses that have probably struggled the most because they maybe buy in smaller quantities of hundreds and thousands, maybe a month. And obviously they have a very, very tiny business with a particular semiconductor vendor. They're probably purchased through some third party like a distributor. And so, if they're stuck and can't manufacture anything, they really don't have a voice to be able to go out there and convince people that, why they should have priority over somebody else who's obviously buying millions of parts per month. So forecasting is an important thing. For example, Steve Sanghi from Microchip Technology, in one of his regular open letters, he announced that there's going to be a preferred supplier program. And for people or companies offering a 12-month uncancelable backlog, they would sort of get some preferential treatment when it comes to delivery of parts when they become available. And that is sort of really essential. Obviously, if you need 3 to 6 months to manufacture or something, you really need to have a very good feel for how many of those you're actually going to sell. Infineon as well, there was an interview on, I think it was on CNBC with Reinhard Plus from Infineon, and he basically said that he'd never seen anything like the state that we were in today. Even the mobile phone boom of the early 2000s was nowhere near as challenging as the situation that they were finding themselves in with delivery issues. And I also had the opportunity to talk to Asif Chowdhury from UTAC. UTAC is a chip assembly and test supplier. So they receive the dies from silicon manufacturers, and they put them into the packaging with the metal legs or the balls, and place the plastic packaging around them. And what he was saying that basically we're just continuously on the telephone trying to resolve delivery issues. The issues also were with run-of-the-mill packages, so SOIC, QFN packages were the issue. And for the lead frame, so that's the metal part of the package which forms the pins, he was saying that some of their lead frame suppliers were simply not accepting any new orders, and there were lead times of up to 12 weeks. So when we wrap all that information up, it's helpful to sort of have a feeling of what can we do, and this is this recommendation has also come from talking to people over the last 12 months in the industry. And one of the most important things is to make sure you build up supplier relationships. Oftentimes, there's a discussion and fight about pricing, and these supplier relationships can be very transactional. I need some parts. We order the parts. We expect them to arrive in a week or so. But it's definitely worth, I think now, bearing in mind what's happened over the last 12 to 24 months, is looking how you can build up your supplier relationships and improve them, and also make sure that you can, as far as possible, share forecasts about what it is that you need. There's definitely parts of the world, especially in automotive, we've seen that with, I think it was with Toyota, part of their sort of just-in-time manufacturing process has sort of been put to one side, and rather than just plan that everything arrives on the day when it's needed, they're actually still starting to build up some stock of 30 to 60 days to make sure that they don't go short of critical semiconductors for their vehicles. So even the big guys are taking a step back, and rather than focus on optimizations and cost downs, they're actually taking a step back and saying, well, actually, availability is an important part of how everything works, and we've sort of ignored that for a while. So we're bringing that back in to make sure that we stay on top of that. Another recent article that we looked at was on motor control. Now, I think it's quite interesting. You get perhaps the feeling when you go to an exhibition that motor control is very much focused on replacing brushed DC motors and moving on to brushless DC motors and permanent magnet synchronous motors in order to attain all of the power efficiencies that those offer, to reduce heat generation, reduce power consumption, and so on and so forth. But the reality is still that there's many fractional horsepower DC brush motors in use today, and the control of those. An example would be the wing mirrors of a car, for example, so that the mirrors can be controlled and the angle can be changed. And the because they're so common, the semiconductor industry has responded with lots of different highly integrated H bridges, which make it much easier to control those fractional horsepower DC motors. Those sort of devices, if you look around, they're not just include the MOSFETs that you need to create the H-bridge, but they also include lots of diagnostics and protection. So, for example, should it overheat, if there's short circuits and so on and so forth, the protection kicks in to protect the part and also the rest of the circuit. And via interfaces like SPI, it's possible then to draw out diagnostic information, which can be evaluated by a microcontroller and then fed back into the larger system. Another interesting aspect of motor control is trying to implement the actual control algorithm, and PID algorithms are often used. But the challenge with the PID algorithm is it is relatively software intensive, processor intensive to implement. So if you're looking at cheaper 8-bit microcontrollers to reach a specific price point for your application, you may find that there's not enough performance there to calculate the PID control loop in a reasonable time frame in order to provide the control that you need for your application. So what was interesting was looking around on the market, what's there today. The PIC16F1619, for example, that's a microcontroller that actually integrates a hardware PID controller. And once it's been set up, it's possible with that particular hardware module to execute a PID loop in 9 clock cycles rather than the 1,000 or more clock cycles it would require to do the same thing in software. So even in that space of DC motor control, which is relatively simple and easy to implement, there's still advancements and developments going on to improve the microcontroller solutions out there on the market. On the brushless DC side and permanent magnet synchronous motor side, obviously there's lots going on there as well to try and simplify the control of those motors and make it easier to bring products to market. And one of the microcontrollers we looked at in the article there was the Toshiba TXZ4A+. Now that particular microcontroller is an ARM Cortex-based microcontroller, but it also integrates what they call their vector engine. And that vector engine implements the entire Clark-Park algorithm in hardware. It links also to the AT converter and also to the PWM module. And once it's set up, it's almost independent. It requires just a sort of an interrupt every so often to keep it up to date. But essentially, the whole algorithm, the field-oriented control algorithm, is implemented in hardware, and that means that the microcontroller can then be used to focus on other parts of the application and simplifies the whole implementation. Someone else we spoke to was Jonas Proger from Trinamic, which is now part of Analog Devices, and they're well known for their motor control devices and silicon. And what he was saying that the control loops today are operating at much higher frequencies than in the past, sometimes up to 100 kilohertz. And that type of fast control loop actually needs a DSP or an FPGA to implement it normally. But devices that they have in their portfolio, something like the TMC 4671, that can actually handle that with dedicated hardware. And that makes it obviously, again, easier to implement. It brings the cost down, brings the number of devices down to implement your application. Another focus of the industry today, he was telling us as well, was about the reduction of audible noise from motors such as servo motors. And so there's a drive to almost silent operation, and there's a big market looking at how they can reduce the audible noise. So what they have integrated into some of their parts is a voltage chopping technique, which they use, and that helps to reduce the audible noise by 10 decibels in stepper motors. So that's what the motor control article covers. If you've just joined us, you're here with Stuart Cording in the Elektor Engineering Insights live stream. This is our regular live stream that goes out on Wednesdays around every month. And we're just taking a review of the articles that have been covered by the industry team here at Elektor over the past 12 months. Another interesting article, which I think is brings together lots of different pieces of manufacturing, industrial space, and machine learning, was our article on moving from preventative maintenance towards predictive maintenance. one of the interesting things was in researching the background of this was that many continuous improvement programs have really reached the limits of what they can do. So continuous improvement programs focus on sort of finding problems, working as a team to resolve that issue, and then implementing the improvements to avoid that issue occurring again, which might result in some sort of quality defect in whatever it is you're manufacturing. One of the examples we looked at was a bulb manufacturer, Osram, who are manufacturing lamps for the automotive industry. And one of the big challenges that they were seeing was precisely that if they were going to make any more improvements, implement the improvements was going to cost a lot of money, much more than they were going to end up in savings. But the improvements were still there to be made. So was there something that they could do in order to sort of still make the improvements they wanted to, but maybe in a bit more coordinated fashion? And one of the interesting things there is to see how they can use machine learning on top of the existing industrial IoT manufacturing platforms that they have in place. So with industrial IoT, most of the machinery in a factory is already connected with one another and to central computers that collect all the data regarding the manufacturing process, regarding temperatures in ovens and pressures, the speed of motors, maybe power consumption, and all of that can be analyzed using machine learning algorithms to predict at what point a particular part of the process may fail or is at risk of failing. And the idea, obviously, is to see in advance that maybe a furnace it has a problem, and to then send an engineer to examine that before the furnace actually fails and maybe falls out for several hours because of that. This challenge is known as calculating the remaining useful life, or RUL, which we use to determine when something's going to fail. Now, one of the interesting things about this, about all machine learning, is the fact that you need huge quantities of data in order to develop these algorithms and bring them to market and use them and implement them usefully. So, but the issue is with lots of environments, you're measuring and collecting data on something that's actually working, and you don't actually have the data to see when it fails. It fails now, and you've got a very small amount of failure data to go on. So, organizations such as NASA, for example, they have been collecting data on turbofan engines. Now, these aerospace engines are fitted out with many, many sensors, and they're continuously monitored, and the data is collected in order to assess the functionality of the motor when it's being repaired. They can then look at the data and see what could possibly go wrong. And not only have they collected the data of the turbofan, they've also collected it right up to the point where the turbofan failed. And the interesting thing there is that you can then go through that data and analyze it and develop a predictive algorithm which is capable of saying, inside the next, say, 30 days, it looks like this engine will fail, and therefore now is the right time to go ahead and maybe service it. And potentially, this is what we think the problem could be. So we found a Munich-based business called Double Slash, and they'd actually developed a prediction algorithm based upon this data from NASA. And it was interesting to see that their algorithm managed to correctly predict on 63 occasions that a pending failure would occur in the next 30 days. It also predicted incorrectly that a failure would occur on 12 occasions. But probably the most important part of that project was the fact that it didn't miss a failure. So there was no case where a failure would have occurred which remained undetected. So it shows that the predictive failure technology and machine learning to achieve that is possible. Obviously requires a lot of research and work and analysis and data to do that, but it's an area that is current and under development. There was also another project from the Fraunhofer Institute called AI FES, and they've developed a C-based C language library for microcontrollers to implement, again, machine learning technology. And I think this is one of the challenges that we're all facing in the industry at the minute is this question of where we implement our machine learning and how we implement it. Obviously, some machine learning needs to occur at the edge, because that is where the sensor and also the actuator are actually implemented. So, for example, in a motor control system, if we are able to detect a pending failure, then we actually need to turn the motor off immediately in order to avoid some sort of failure occurring or damage to the equipment, or even injury to personnel who are working in the area. So it's people are trying to avoid moving the data to a cloud-based machine learning algorithm, because the latency of that may not be fast enough to ensure that safety can be guaranteed. So the project from Fraunhofer Institute, what they showed was that not only could they create a very small footprint C language-based machine learning library, which was good for gesture recognition, also for handwriting recognition. It also was capable of supporting, of actually being trained on the microcontroller. And that means that you don't need additional resources, say a separate high-powered processor or even a cloud-based machine learning algorithm in order to train the algorithm and get it ready. So that's an overview of the types of articles that we cover here at Elektor. If you'd like to see any more of those, you can see all of the Elektor articles that I write at ttcr.at/Stuart@Elektor. There's a list of the articles that we write for the Elektor magazine. So some are more focused on the hobby community, some are more background pieces, and others are focused more on the industrial space, like our show here today. So you're watching the Elektor Engineering Insights show. This is our inaugural show, and it's slowly coming to the end. I'd like to thank everybody for joining us today. I hope you've enjoyed the show and you've developed a feeling for what to expect in the future. You've seen also some of the topics that we're planning to cover and some of the guests we're planning to have on. And if you'd like to join us as a guest, why not get in touch with us by email, via Twitter, or you can reach out to me, Stuart Cording, on LinkedIn. And if you'd like to see what's on the upcoming schedule, everything will be updated regularly on the Elektor Engineering Insights page, and that's available at ttcr.at/EI. So drop by, take a look, and you'll find everything that you need there, and also access to all of the other articles that I contribute to the Elektor magazine. So thanks very much for joining us today. Stay in touch and don't forget to keep asking us your engineering questions, and we look forward to seeing you again soon.